Hello guys, I'm very excited to share with you guys about Google's engine. As this title indicates, Google's engine is a remote sensing big data platform. And today, I'd like to share with you the chapter 1 to know Google's engine, aka what is Google's engine. So what is Google's engine? Put it simple, Google's engine is an online platform to processing tons of remote sensing data. It has three very obvious features that are different from other platforms. First, it's a research oriented. It's not just for programmers. You don't need to know much deep into codes, and you can use this platform smoothly. Secondly, it's free. It is free to use Google's supercomputation facility. Actually, Google has stored all the open source remote sensing data like Landsat and Sentinel into its hard drive matrix, so we can just use them as they are already downloaded. Secondly, the most eminent feature of Google's engine is that it makes large-scale geospatial analysis much easier. Imagine this, if you want to analyze all the Landsat images in Australia or in America, you need to download these images first, like 3,000, 4,000 images, which is 4,000 gigabits. It's a large amount of data, but in Google's engine, just one line of code, and then you tell Google's engine that I want to analyze these Landsat images. And those images will just pump up and ready to be analyzed. So, based on that, what is Google's engine actually? If we can have a deeper look, we will see that it is a data processing tool developed by Google. We can compare Google's engine as other tools like TensorFlow, as Google Earth, or etc. It is a sub it is a team in Google that are responsible for this platform. Secondly, Google's engine is its name is very similar to one of the famous Google's software, Google Earth, but they are very different. Let me show you. Here I open an Google Earth, and in Google Earth, as many people already know, we can observe the Earth very easily, and it has very high definition images in this platform. But as we can see, we are more observing in this Google Earth software. Actually, Google Earth has many calculating or analyzing tools, but they are very basic, like this calculating distance, or we can import some boundaries, some shapefile into it. But most of all, Google Earth in this platform, it is for observing the world. But for Google's engine, GEE, it is more of analyzing, like ArcGIS or QGIS. Anyone who has a background of geographic information system will get to know that Google's engine is is mostly for analyzing. That is the most important difference between Google Earth and Google's engine. Secondly, Google's engine is very similar to other GIS software like ArcGIS, but their foremost difference is that Google's engine is a code-based platform. Yes, I know it is boring to say what is Google's engine and how important, how different it is. So let's just jump into how to use Google's engine. First thing first, you need to register first. The register link can be found here. Let's jump into Google and type in Google's engine. And click the first link. Here we come to the website of Google's engine. If we want to use this fantastic platform, first thing we need to sign up. I have already registered and signed up, and here's the page of that if you have passed the registration. It took like two to 3 days. It really depends. You need to fill in your some of your information and to tell Google Earth team what you want to use of this platform. This is quite a simple task. After the registration, we can click here, Platform and Code Editor. This is the core area of Google's engine because all our operations can be deployed here. This is the main window of Google's platform. We will dig into each column in detail later. But now let me show you some other important thing is that you have to know something about JavaScript so you can use Google's engine. But I can assure you that some very basic understanding is enough for most cases. All right, these are the two preliminary steps for using Google's engine. Now let's get to know something very basic about Google's engine. I have two simple tasks that can demonstrate how powerful Google's Earth engine is. The first example, I will show you make a cloud frame mosaic of Landsat images of your, aka my, hometown. And secondly, I will show you how to calculating the NDVI in Google's engine. Here we are in Google's engine. If we want to make a cloud-free Landsat image of my hometown, the first thing first is to find my hometown. Second thing is to use Google GEE, cloud-free algorithm. Second thing is to add the cloud-free map into this browser. Let's focus on the first one, find my hometown. I'm from China and my hometown is named Jiaozhou. So here it will jump up. When I click this, it will take me to my hometown. It may be Chinese character, you don't know that, but it's okay. Let's change it to Earth map. After finding my hometown, I need something to tell Google's engine that this is my hometown. So I will move my mouse here and click this add point sign and click a point here. Upon clicking a point here, there will be its coordinate will be automatically introduced to Google's engine. And what we need to do is just to rename it. I will rename it point hometown. So here we finished the first one. We introduced an point to demonstrate where my hometown is. After finding my hometown, the second thing, sorry I forget one thing, is to introduce Landsat 8 imagery. It's quite simple. In the search box, we just need to type in Landsat 8. Here we will use Landsat 8 raw scenes because the cloud-free algorithm is suitable for the Landsat 8 for raw scenes. To make things more clearly, we will rename it as L8 raw. So we finished the second step. The third step is to use Google Earth Engine's cloud-free algorithm. I will show you. It's in these docs, and its name is Simple Composite. Upon clicking this, I will copy all the code here and pasted it there. In this step, we should first type in var, which is JavaScript tradition to tell the computer we want to introduce a variable. Var cloud free equals. Here we can type in all the parameters. As this collection is which imagery we want to process. It is L8 row. And behind it is percentage cloud score max steps as float. We can say these are optional parameters and they have very detailed or very intuitive description here. As in this simple example, we will just skip all these parameters. Just forget something very important. First thing first, whenever we introduce some data, the first thing we need to do is to filter the data. We don't want to every Landsat 8 raw images like thousands to be analyzed here. So first, we will introduce a bounce. The bounce is already introduced. It's a point in my hometown. So secondly, we want to using a specific time range to reduce the amount of data. So let's say L8 filtered equals L8 row. This is the all the Landsat images. First thing is first filter bounds. I will use my hometown point as the bounds to filter this Landsat 8 row. Second thing is filter dates. Let's say 2018. I don't know why it's just jumping in my head and things like this. So what this line of code is telling Google's engine, I want all these Landsat 8 imagery. First, they are filtered by a geographical point, and secondly, they are filtered by a data range. So this filtered land imagery can be analyzed here. Okay, the last thing what we need to do is to add the cloud-free map into this browser. The command is here, map.add layer, and we put this cloud-free image here. After hit the run, we will see a cloud-free image. And it's a grayscale imagery. It is because we are not specify the imagery parameters, showing parameters. We can define the visualization parameter here, 4543, and here we specify 80. I will explain that later, but now we just take it as a given. Here we are generating this cloud-free imagery. We can see that there are some white white things here. It's because there are much cloud, and this algorithm has erased the pixel because of there are clouds. Okay, zoom out a little bit. We can see the Google's engine is analyzing this specific scene of Landsat images. So, as a result, with these 3 lines of code, the Google's engine has already analyzed all the Landsat images in here in this position and choose the best quality pixels to make a mosaic of cloud-free imagery. That is quite fantastic. After doing that, we can now calculating the NDVI. Here I put this target here. As I said, first thing first, we need to type in var, tell Google's engine we want to create a variable. Var NDVI equals Google's engine has a built-in algorithm to calculate normalized difference. It will be We can find it here. Normalize the difference. I, Personally, I like copy and paste because it will make sure that all the typings are correct. Here we can see this normalized difference. Before this normalized difference, it's an image algorithm. So we need first put this cloud free here and using a dot to demonstrate to show that this normalized difference algorithm is for this cloud free image. And we in this bracket we should specify which bands we want to use to calculate normalized difference. It will be B4, B5, and B4. Single quote, double quote is okay. And next thing is we will add this imagery into this browser, NDVI. And I hit run. Now that it becomes two layer. We can see it's a whole gray layer because we are not specifying visualization parameters. Here we can choose 2 sigma, using 2 sigma to regulate its visualization. And I hit apply. It will have this kind of visualization effects, and we can apply some color map for a better, more appreciable visualization effects. So quite simple. But if you want to do the same thing in your personal computer, it will be takes like a little bit longer to generate this cloud-free imagery because you need to put all the data sets into your computer, which is a quite huge uh, amount of data sets. So this is the first thing I want to show you. It's about what is Google's engine and some of its basic functions. I hope we can have a more enjoyable time in learning this fantastic platform. I'll see you around. Bye.